Hello everyone, for today's topic you're going to learn about the classification of electrodes. So how do you define electrode? Electrode is a conductor in the form of wire, rod, or plate which carries electric current in and out of electrolyte during electrolysis. So I hope that you still remember our previous topic, which is all about electrochemistry. So how do you define electrode? Electrode is a conductor in the form of wire, rod, or plate which carries electric current in and out of electrolyte during electrolysis. So I hope that you still remember our previous topic, which is all about electrochemistry. Active electrode. It is an electrode which takes part in the chemical reactions during electrolysis. Examples are metal electrodes such as copper, silver, and mercury. Next is we have this inert electrode. It is an electrode which does not partake any chemical reactions during electrolysis. Examples are carbon and platinum electrodes. Anode. It is an electrode which is connected to the positive terminal of the source of electricity in an electrolytic cell. And the last one is cathode. Cathode is an electrode which is connected to the negative terminal to the source of electricity in an electrolytic cell.
In this video, we're going to learn about electroplating. Electroplating is the process of coating one metal object with another. It works by electrolysis, which is when electricity is used to drive a chemical reaction. We're going to look at why you would want to electroplate, how it works, and various conditions that need to be considered. So why would we want to do electroplating? Metals may be electroplated for aesthetics, protection, or both. Aesthetics might involve making a metal shinier or giving it an attractive colour by coating. For example, jewellery is often plated with gold or silver. A metal coating can be used for protection, as it may help resist corrosion, rusting, or just general wear and tear. Car rims are electroplated for both shininess and protection. Chromium, commonly known as chrome, nickel, tin, zinc, and cadmium are often used to plate copper, iron, and steel objects. Tin cans are actually made of steel but have a thin tin coating. Ed White, the astronaut who made the first American spacewalk in 1965, was wearing a gold-plated visor to protect his eyes from the solar radiation. So how does electroplating work? An electric current is passed through a solution that conducts electricity, called an electrolyte. To create this current, two electrodes are dipped into the electrolyte solution and connected to a battery or power supply. So we end up with a setup that looks something like this. When the current is turned on, the electrodes gain a charge. The positively charged electrode is called the anode, and the negatively charged electrode is called the cathode. The electrodes in an electrolyte are carefully chosen based upon what metal you are plating with. So if you want to copper plate another metal, you will use a copper-based electrolyte solution and have a copper anode. The copper for the plating comes from the electrolyte solution, which in turn has its stocks replenished by the copper anode. So let's look at copper plating as an example. We want to copper plate some brass. So we have a copper anode, a brass cathode, and a copper-based solution for the electrolyte. So copper sulfate solution. Copper sulfate solution contains blue copper ions and colourless sulfate ions. The copper ions are positively charged and so are attracted to the negatively charged brass cathode. The copper ions deposit onto the brass, producing the thin copper plate. The positively charged copper ions gain electrons, which is known as reduction. The sulfate ions are negatively charged and so are attracted to the positively charged copper anode. The current supplied to the anode causes the copper atoms to oxidize, which is lose electrons, and then dissolve into the electrolyte solution. So the copper ions move from the anode to the cathode in the solution, and the electrons move from the anode to the cathode, but along the wire. The copper anode bar gradually dissolves to replenish the copper ions in the electrolyte solution, so the solution stays at the same concentration. If another metal was used at the anode, then the copper sulfate solution would get paler or less concentrated. So just remember that oxidation, the loss of electrons, takes place at the anode, and reduction, the gain of electrons, takes place at the cathode. So a few other things to consider in electroplating. The speed at which electroplating occurs depends only upon the strength of the electric current. A stronger current increases the speed at which the ions and electrons move through the circuit, speeding up the plating process. One way to increase the current is by increasing the concentration of ions in the solution. It is also important to choose your metals carefully in electroplating. Not all metals will alloy with each other. For example, steel has to be copper plated and then silver plated because it will not form a direct alloy with silver. There are also environmental concerns associated with some metals. Chrome plating, for example, creates waste materials which are dangerous to humans and animals. Waste products have to be treated accordingly to make sure they are safe, which can be very expensive. And finally, most importantly, for current to flow, the ions need to be able to move. So the compound must be molten or dissolved in a solution. So in conclusion, from this video, you should understand how electroplating works using electrolysis. When the current flows, the positive ions in the electrolyte solution move towards the negative cathode where they gain electrons, which is reduction. And this is what causes the plating to occur. At the anode, the current causes the metal atoms to lose electrons and dissolve into the electrolyte solution. The electrons, which the metal atoms lose, flow back to the power source and around to the cathode. Losing electrons at the anode is known as oxidation. So just remember, we have reduction at the cathode and oxidation at the anode, and that's electroplating.